Okay. Well, as Lonnie mentioned, BG is one of the largest gas utility in America. It ranked in the top 10, considering even the U.S. You know, they operate on a regulated framework. That means that basically they cannot charge onto customer whatever they want. They are no open on a free market business. So they need to pass through what is called a rate review process in order to define their tariffs, to define how much they are allowed to pay onto customers. So that process, you can imagine how challenging it is for a utility. It takes place every 5 years, and it is for them like betting your old business in that process. So at that moment in time, well, BG people that are the main owners of Comgas go to Brazil and ask them, okay, before we get into this process, please, would you mind to answer me which are the tariffs that maximize our business value? Yeah, I know regulation will impose some constraint on us, but let's first figure out what we want before we get into that negotiation process. So at that moment, we were invited to help on answering that question. That turned out to be, even though straightforward question, a very difficult to answer. In what sense? We initially need to capture, we'll be playing with rates. I'll be pointing out here. Okay. We'll be playing with tariffs, with rates. So we need to capture demand elasticity, so how that rates will be affecting demand. But at the same time, we need to consider supplying gas to those customers, whether our gas was enough to supply to those customers, or how many contracts you need to dispatch in order to supply that demand. And turns out that the gas, the cost of the direct cost of gas, is a main component of tariff at the same time. So it's like we have a loop here. At that moment, we say, well, okay, solving that, we are ready. We have demand, we have rates, we can calculate revenue, and let's maximize revenue. But someone say, okay, you know, if we maximize revenue, not necessarily that means maximizing our business value. So they say we should consider the OPEX. So the more demand we attend, we need to build up a driver-based OPEX, something that reacts according to the demand we were attending. And someone said at that point, well, analyzing our entire cost base, we realized that we have, of course, demand, it's the main driver of OPEX, but at the same time we have the infrastructure, the network, basically. It's the other main driver. So we need to keep into account how the infrastructure will grow in order to attend that demand. And that will become a driver of OPEX at the same time. And there was a financial guy in that meeting and say, okay, you know what? Investment, it usually comes with debts, new debts. So we need to consider how we'll be financing those investments. And at the same time, they say, okay, if we want to really capture net business value for the shareholder, we need to project complete financial statements in order to get the dividend that will be paid to BG, that will be the rate, the net present value of that, the value that we want to maximize.
Okay, so you can see all those interactions that are going on. Imagine with all those individual spreadsheets, these business units like this demand, you know, they're not taking into account those interactions. So to do this problem the way they want to do it, really it requires going to our first theme here, an integrated planning approach, where we basically take a model of the entire business. It has all those business unit logic from the spreadsheets combined into one where we can run these analysis in a holistic fashion. And so when looking at how to do this, there's really sort of two approaches to that. And you know, there's possibility of using desktop applications like Excel, extending that to it, or looking at enterprise management systems. So, you know, step one, of course, is to consider which way would be the most expedient way to go about doing this. And so we looked at both quite carefully. Now, they had a very big concern over analysts' ownership and control, as well as the flexibility to be able to build these models that they've been building in spreadsheets. And they really wanted to be able to understand how things work when they were done. So those were big, important factors. But, of course, being able to integrate this and stuff are nice factors of business intelligence systems. We looked at these systems in some depth, trying to figure out how could we go about putting that kind of logic into these systems. And I might as well hit the space bar. We saw a talk yesterday that talked about how these were sort of built for the past, and they're sort of trying to move into the future. And you can do stuff, but they're just ill-suited. Well, that historical emphasis made that extremely difficult, almost to the point of infeasibility. And when they wanted to make modifications, they had to call up the IT department or the Cognos consultants to do the work for them. So they found that very dissatisfying. So our first approach was to actually attempt doing it with spreadsheets. Jorge?
And, well, let me tell you the end of the story. Well, we did it initially with a spreadsheet. It was painful, but we did it. The tariff review, we were able to determine the tariff that maximized business value. We built up a model, an Excel spreadsheet-based model, linking all together. As I mentioned, was very difficult to use at that time. So in certain way, we achieved the objective of determining what we were looking for. But to be honest, we failed in two of the main goals they asked for. That was, they wanted to be in control of the process. This process is such important for them that they wanted to keep control on them. They want to keep understanding how information flow in all the diagram. And that was impossible with that model. We were the only one who were able to operate such a model. It was huge. We couldn't open the entire model altogether in order to update links. So we need to close some, open the rest. Well, you're well familiar working with large models with spreadsheets.
So this brings up our second theme. It's analyst control and ownership. Okay? These analysts just felt it was absolutely essential that they still had the flexibility to model their business units, to be able to explore in a very flexible way like they can do in Excel. And that was really kind of what drove that decision to attempt the Excel spreadsheets. But as we mentioned, let's go ahead, the Excel spreadsheets really were not up to the task, even though it was functionally possible to do it, as proved. It did not, just was not satisfactory. So the question is, where could we go from here? How could we get the best of both solutions? An integrated planning solution, the flexibility of modeling power that's something better than Excel, that can handle that kind of complexity, retaining ownership control with analysts, but still being enterprise-wide up to corporate level standards and with this distinct focus on decisions. So this leads us to CubePlan, which, by the way, this project started about, what, 7 years ago, roughly? Yeah, so, it was a major motivator in the evolution of this system. Okay? So here we have an actual CubePlan model. Because of proprietary issues, this is not the actual ComGas model, but it's one of pretty much the same scope. It's very similar. It's of an electrical utility. So it's going to, for all practical purposes, you can pretend you're seeing the ComGas model. First thing to notice, this is not a PowerPoint slide. This is the actual model right here. And it's highly interpretable. You can see these look just like, the business units are there as modules. You can see influences between them. Very intuitive what that structure is. Let me kind of show you the scope of this model, okay? Because it's a comprehensive model. You might think, well, that doesn't sound very feasible, but here it is. We're going to jump into demand projection here. See that there's modeling of all the different segments here: industrial, commercial, residential, public lighting. I want to jump into residential. And see, it goes down several levels. And some of these nodes are variables here that are being computed. This gives a nice visual depiction of how things are being computed and what's going on. A little bit louder?
Yeah, it indicates something. There's a convention about what are parameters, in this case the yellow ones. Blue ones means calculations, intermediate variables. And we have the output of this model. On any model you get into, the color indicates what is the output, the main output of that model. And then you have some other colors, reports or those types of stuff, or information that is read from legacy system, from SAP or whatever information you are feeding the model with.
Okay. Thanks for that question. That was good. Residential customers. So you can see well, actually, it goes down a few more levels. We don't have to jump into there right now. Let's go up to the top level again. Very top level. So you kind of get an idea of the scope of this business unit. Let's look at supply again, just to get an idea. Goes down a few levels here. How about contract nomination? This would be where the model's kind of figuring out which energy supplier is going to provide power to meet the demand. Contract dispatch is doing that calculation. Okay, we get to look at a result here. Okay, so yeah, this is a neat calculation right here, actually, because this is an example of a calculation that's really hard to do in Excel. I mean, people give up on this calculation. It's actually a multi-dimensional result here. There's 5 dimensions to this problem. We have sources of the energy contracts. This would be the providers of energy here. In this case, they're labeled hydro, wind, geothermal, coal, natural gas. We have the hours of the day. We have time, day of week, and the distribution companies that are sending the power out. So here's the scenario, basically. Imagine you have this demand for energy, for electricity or gas, in this case electricity, and you have a section of suppliers you can provide that energy from. Well, what are you going to do? You're going to tap the cheapest energy source first, right? Once that's used up, there's a certain capacity that can be provided from that energy source. You're going to go to the next most expensive, and that's called dispatch. And so this here is actually showing during this particular day of the week and day of the year. This would be the typical dispatch that you would use as far as how much of each type of energy you'd be providing. There's a key down here. So again, this is kind of interesting. I mean, it's hard to appreciate, but it's an example of a calculation that people just give up on when they try to do it in Excel. So it's kind of a neat example. Okay. Should we, actually, I'll show you. Should we pivot that? Does that one make a good pivot? Does that make a good example of pivoting?
Okay. Let's do it.
Since we're there. Okay. So another neat thing about this, you've seen this with OLAP cubes, I'm sure, but as a 5-dimensional result, you can slice and dice and pivot and all that kind of stuff. So
let me show you how demands evolve in time. So adding up the hours, and let's show the entire period of time. Here we are. There it is. That is the total projected demand, how that they will be satisfied by each energy source. And this is open by...
So this is by month now on this axis.
Sorry.
See? Yeah. You see how it varies by month and stuff.
And we can see that working for 3 different companies.
Yeah. One thing that's kind of neat about this pivoting you're seeing here too is if you're familiar with OLAP cubes and you slice and dice and pivot on those, you're looking at historical data. You're just getting different aggregate views of that data and looking at it in different ways. This is actually projections that are being computed in a very rich way with expert knowledge going forward. It's not like there's a database of data there. It's sort of computing all these scenarios or all these situations and giving you that same slice dice capability. So, okay, let's close that off. And so this was demand, supply. Let's open CapEx and...
Well, in the CapEx case, we have like 2 sources of CapEx. One is project-based, the other is variable-based. The project-based, it's meant for the CapEx that you have the right to decide to invest or not. So it's something that you choose to do it. But the variable CapEx is something that is driven by your demand. For example, in this case, you install a new meter for every new customer you have. So that's something that is compulsory for you to do it. So with these 2 sources, in the first column, you can see the cash flow calculation of those investments. Then it capitalizes manpower, it capitalizes financial charges. Then we have a date of capitalization. Up to that point in time, all those investments are work in progress, so they are not depreciated. From that point on, they are allocated to the assets account and start depreciating every one according to the useful life of those accounts.
All right, and go into OpEx also, actually. Yes?
I don't know if I'm jumping the gun here a little bit, but in terms of data inputs that go into the model, where does that sort of process start with? Because you did mention that it's also forward-looking and projecting future results, so obviously you would have to do some kind of forward-thinking analysis. But in terms of getting your actual data
Yes.
in the model, how does that get into it?
Yeah, so I'm going to repeat the question. She's asking, where does the actual data come from? So, of course, there's a lot of rich modeling logic here, and it's going to obviously need to feed off of some raw data from various departments. How does that feed into this logic? And
let's just show you a couple of more things and go direct to answer your question. The OpEx model I already mentioned, it's a driver-based OpEx model. So we read the base year OpEx from SAP, that's another data source, the last year OpEx. Then there's a definition of drivers. For every asset account, every activity you have, you define a driver, which is how do you project that into the future. So that allows you to test scenarios, basically. That's what you want your OpEx for. So with that, in this case, there has some efficiency programs. So at the end of this part, you get the OpEx projected in real terms. Then again, you have a definition of which index will allows you to transform the real terms in nominal terms. Because this is multi-currency, so it operates in different countries. There are some things that are adjusted by local inflation index, some from exchange rates or whatever you define. It's more appropriate to transform real terms in nominal terms. And last but not least for you is complete financial statements. Here, well, haven't been mentioned, but this is made entirely customized on a case by case. We are looking at a specific case right now. It is calculated the P&L the way the company that calculated. Yeah, so it is not a template that you need to adjust to. Be totally the other way around. This is entirely customized to your needs. Okay, let's go to answer.
Okay, go to the top level here, and let's go ahead and push the P&L result. So you notice here we've put a little control panel with quick access to various results of high interest. So you push the P&L one, and you can see the P&L report was actually calculated from the model, and you can see the results there. He's also showing how you can graph certain line items with a few clicks of the button there. Okay.
It looks silly, but it's a powerful thing, since you don't make a graph of any single line you have in a spreadsheet. So being able to draft whatever variable whatever step in the calculation process you make, it considerably reduce the possibility of making mistakes, making errors. So you see accounts, how they move, and it's very easy to detect strange behaviors. Okay. Yeah, something that is hidden when you just see numbers.
Okay, let's go up to the top level, and let's drill down into demand projection again. And let's get down to the residential part and look at some of these variables in a little more depth. Just a side note right now, you guys might not realize this. This is running in a web browser right here. The model itself is located on a web server, everything centralized. I didn't actually make that point earlier, so it's kind of an interesting thing. Okay, so let's look at this variable right here. It says projected residential customers. Okay? Well, why don't we show the results so it makes it a little more meaningful. So how many residential customers are we going to have? And you know, there's a computation of that, and we can see the result. Now, if you're doing strategic planning, or using these numbers in other ways, or diagnosing problems that have occurred, you're likely to say, well, where are those numbers coming from? I want a little more information. I want to understand that. And so here is where the influence diagram is an awesome tool for communication. Okay? People, both technical and non-technical, can look at this diagram and understand where this is coming from at the appropriate level of detail. Okay? They don't want to look at mathematical formulas or something, right? So what you can see here, pay attention, because I'm going to give you guys an exercise. It says that projected residential customers is a function of projected population, okay, and projected average household size. Okay? Think about that. I'm going to say, how is that computed? And I'm going to put you guys on the spot. Okay? So if you know the projected population, you know the projected average household size, how would you compute the number of residential customers? Okay, a customer is like a household, right? Okay? Somebody want to volunteer, or should I come around and pick on somebody?
I'll set myself up. Drive one by the other.
That's very good, very good.
Correct.
Okay.
You
now
won,
he gets the
you won a lunch.
he gets the award for the smart one here. So you guys lost out. Awesome. Okay. He's exactly right too. So you see here's the actual definition of that variable. It says res pop projection. That's the meaningful identifier for the variable. Residential population projected. Residential pro household. And just divided. So very intuitive. Notice they're meaningful identifiers, not E7 times C6. Okay, that's very helpful.
You can switch to see the titles of the nodes and the identifier that is basically the name of the variable.
Yeah, we often want to have an easier, shorter variable name. When
so answering directly to your question, the information the information provided is basically the yellow nodes. So we have historical population by region, historical households, and long-term average ratio that we want to mature to. So that's the initial values. The rest of things are calculated in the model up to determine what's the residential projection.
So it's basically key in your assumptions at that point in time to stress what's going to happen.
Yeah. So let me show you a couple of things here. This is the historical households. So this is historical average. You can see range from 4, 6, 7. Numbers are made up. And we say we want to achieve something of this ratio, from 6 that we are to 2. Yeah, because we are assuming the economic growth. So people tend to be in smaller families. So that's the way it is calculated.
Can you put the definition back up for the projected residential customers?
Oh, sorry, you were raising your hand? Sorry? Sorry.
So she's asking, where do we put the future assumptions in?
It is here. This is the future assumption, and here is calculated how you go from the point you are to what's your objective.
Yeah, assumptions come in numerous forms, actually, so we want to be careful about that. You may have assumptions about specific parameter values, like I'm going to assume that the average increase in the price of oil is going to be a certain rate. You may also have basic assumptions that are more structural in nature, more logical in nature, okay? And those are really embedded throughout the logic of the model in these variable definitions. And in fact, I think it might be interesting to kind of build something onto this right now to kind of demonstrate how we do that. Although I probably want to just explain one more thing about the definition of this that we didn't quite cover.
So as you can see, all nodes have definition. Yeah. So in certain way, they are equivalent to the Excel cell. But instead of being a cell, it's a computational matrix. They are multidimensional matrices. So that's the power where it resides.
When we looked at this result earlier, it was actually a three-dimensional result when we looked at here. But no dimensions are mentioned here. Okay? It doesn't mention the fact that This result actually is indexed across time. It's indexed across building, is it building type?
Building type.
Unit type. And it's indexed across, I can't remember, one other dimension was in there.
Distribution company.
Thank you, distribution companies. Yet none of that appears here. And that's actually a really strong feature. And we call this array abstraction because we don't have to think about, mention those dimensions that aren't relevant to the computation being expressed. Okay? It makes it very easy and intuitive to read. It also makes it very easy for the analysts, when they're building models, to express the relationships. And finally, it makes it really flexible. So if they decided to introduce dimensions later, these expressions don't have to change. They can incorporate those dimensions. Okay, let's go ahead and close this and
We'll demonstrate that.
and demonstrate
in
that a
future
little bit.
example.
Yeah. So, okay, question? Mm-hmm.
Short question. For instance, historical data. Can you involve a lot of people from the organization to put in their historical data for their region? And is there also security in place so that you can only modify your own region?
Mm-hmm.
Can it really be a collaborative process to capture all the data from the organization?
The answer is yes.
Yes.
You can go ahead.
We'll have a topic that will be covering collaboration, how to collaborate. I mean, there's ownership of every part of the model that is assigned, but the answer is yes.
Okay, very good. Suppose now we have this in place and the government, we hear the government is considering a new program that's going to try to move families from multifamily dwellings into single-family dwellings. Okay? And so we want to see what the effects of that might be on our projections and stuff. So
We have changed this example so many times that please tell me which one we will use.
okay, so let's say
I do the wrong one.
Let's first of all say that we think that if that program goes forward, that the number of people in multifamily dwellings would go down by 10%, and the number of single-family dwellings would go up by 10%. Okay, probably not quite right, but make it simple for now. And then let's also say we're not sure when the government's going to actually institute this program. Okay, maybe it'll be next year, maybe it'll be the year after. So we'd like to look at those cases. Why don't you show us how we can do that? Huh?
One at a time. I guess you're
okay.
jumping.
So let's go ahead and look at the first thing. So
okay.
How would you adjust for this household?
Let's call it
change.
Government program, or no, adjusting factor.
Adjustment factor. Okay. Yeah.
Adjustment factor. So variable adjustment factor, and we'll define it as a table indexed by a building type. Okay, there we are. We have our variable. Now let's populate with numbers. So we are saying that the government is changing from multifamily to single family, so we'll have less multifamily in the future. And
1.1. Yeah.
Insist. Okay.
No, I said 1.1. 10% higher. That's 1%.
10%. No,
Yeah.
it should be less. 1.5. Okay, we agree on that.
Difference in expert opinion here.
Yeah. Okay, there we are. We have our indexes. Now let's affect the variable.
Okay. Yeah. Okay. So there we have an adjustment factor. So this is the definition we were looking at earlier, right? This is the residential customers. So we just multiply it by that number, right? Okay. Now that table he put in had two numbers in it, didn't it? It had the 0.9 and the 1.1. He just put in the name of the variable there. He didn't mention the dimension at all. But guess what? Yeah. It computed it, Can we show building type here, say, on the 2 lines, showing building type on each one? Yeah.
Okay.
Okay. You know what? I want to do the second part. We haven't said when that would start, so that graph wasn't too interesting yet. Okay. Let's say there's a starting date now. So.
Okay. Now we are improvising. Murphy's law indicates that something must be going wrong.
That's one thing I love about this. It's so easy to improvise.
Title. This is a
that makes presenting this fun, you know.
Date of change. We indicate it's an index. Date.
I was hoping to actually come up with a hard ball throw. Hey Jorge, can you do this? Catch it behind your back.
And we'll have like 2 scenarios: a base case or an early case. This occurs early in time. And no, later in time.
Okay. So
There
you'll
we
need
are.
to put a date in there, right? So you want it to, early should be that it starts in 2011, and late would be that it starts in 2012.
Okay. I'll create a variable. This is what you want to do. They're going to be starting date. And going to be a table indexed by date of change.
As he's doing this, you might think about that question about assumptions here, right? Think about the different kinds of assumptions that are going on here. You know, we had some assumptions about what percentage change this government program would make. We also have this what if type assumptions here. You know, what if they change it in 2011 or 2012, right? So we're sort of exploring multiple possible assumptions. There's also some amount of structural assumptions in there going on, you know, as far as the fact that that program would actually just, we could model as a percent change, okay? But everything is there. Everything is flexible. And we're doing this on a model that's already created in production, okay, to explore something that they didn't think, you know, nobody had really explored yet, okay? And it's can do it at a
So let's alter the formula. So what we are saying is that we will multiply our original projection by a factor that depends on when the program starts. So when if time is less than the starting date,
and we multiply by
then
1, right?
multiply
We're
by
not gonna
1,
change it, yeah.
else multiply by the factor. Okay, there we are. So we have now starting day influencing the projected demand, and we can see.
Ah, there we see. There's our 2 little bumps for the starting dates, but this is showing, I think I want 2 lines for the 2 different what-ifs. Those are being aggregated the way they were shown. There, that's what I want. Yeah. Okay. So there's a number of residential households. What is this? This is multifamily. Okay. We're seeing the multifamily households for the program that doesn't start till 2011, and we're seeing the one that starts, I'm sorry, that doesn't start till 2012, and the one that starts in 2011. So, okay, very easy to put those in and look at those. So,
And you can see that this variable, previously, it didn't have this index, that it was what we just created, date of change. Yeah, and now it contains. But if you check on the formula, as Lonnie mentioned, there's no the explicit mention to any kind of dimension. So it is intelligent enough to interpret that command, realizing that the date of change has a new index, and then expand the new variable with a new index.
okay. Can I drive? Okay, so you can see how we can make these changes. I want to do a little exploration, a little elaboration on this process here that I think will really help to sort of understand how things are working here. And, you know, analysts want all this control. They want this ability to go in and make these changes. And I'm going to use our development tool. It's the non-web-based version, which if you're making a lot of changes can sometimes be a little more efficient. So I think we're in the model here. I've just dropped down into an empty module node where I can use to demonstrate this. And I just want to make sure the font size is big for demonstration purposes here. So the node's a little bit bigger too. Okay, so what we'll do right now is just create a demand elasticity model from scratch. Okay, so you can kind of see how these things are built up from the ground up. And you know, this can be done to models that exist and sort of elaborate on them and so forth. But you'll find it's very inviting, and it's quite fun to do this. So what I'm going to do here is ultimately...
You do not hear this. We have 20 minutes left, so let's go fast.
Okay, really fast. Okay, so we want to compute profit. Obviously, that's our objective. Okay, we're going to base that on revenue and on expenses. So what we're doing here is we are identifying the core variables that we want to express our problem in. A decision that might be made is what price to charge for products. We have the units that will be sold. We have variable costs, and we have fixed costs. So this is just a starting point. Okay. Now, I haven't actually defined any of these, given them any definitions. But I also, as thinking this through, it's kind of useful to think about how they relate to each other, how they influence each other. Okay, so maybe something along those lines. And this should have said fixed costs. I don't know why I said costs. Okay. So now we have the basic structure of the model there, and we could actually go in and fill in definitions. So, for example, profit would be revenue minus expenses. And this keyboard is in Spanish. Where's minus? There it is. Okay. Very good. Okay. Now, revenue. How do we compute revenue? It's got to be a function of price and units sold. Oh my! I'm overcome by stage fright right now. Help me! How do we do this? Somebody! Price and units sold. Come on. Come on. Oh, thank you. Yes, you heard that? Price times units sold. Thank you. Okay. Gotta wait, make sure. I know this kind of gets drug out, so a little excitement. Okay. Show me where times is on the Spanish keyboard. There we go. Thank you.
I know a program beforehand.
All right, and we'll go ahead here and let's say our product's going to be 1,000 monetary units. I tend to say dollars, but maybe pounds. Suppose we're going to sell 40,000 of them, and we didn't actually define expenses, did we? So that's okay. So we're going to do $1 million of, no, not $1 million. We're going to say it costs us $600 to produce a unit that we're going to sell, and maybe we have $1 million of fixed costs, okay? And expenses. Now, how do we do expenses? Well, it's got to be the fixed costs, of course, right? Plus, I see plus, the variable costs times, there it is, the units sold. Look at that, I forgot to draw the arrow. Bummer. Well, I'll just put it in anyway, and it keeps the arrows consistent for me. Okay. So we actually have a complete model now that we can actually evaluate. We can see what our profit would be. And there it is. $15 million. Looks good, huh? But, well, we might want to actually explore now some different price points. Okay, so instead of charging $1,000, what would it look like if we charged, say, I'm going to replace this with a list, and say we might look at 600 or 800 or 1,000, 1,200, 1,400, $1,600. Okay, various points. So I've just changed price to a list of possible prices, and we go back and look at profit again. And it has actually computed the profit for all of those. So it's basically repeated the model's calculation repeatedly. So I can actually see the result. Here's the graph of that. Okay. Now at this point, we don't actually have demand elasticity in there. So what we really want to do is have units sold go down if price goes up, right? So we need some form of elasticity. So let me move these nodes over a few notches to make room for a few additional nodes. So we will, when we do elasticity, we'll generally relate the price to a base price and see how far we vary from that in terms of a relative price. So let's just say we're going to reference a base price that is, say, our original price of $1,000. Is that 1,000 or 10,000? That's 1,000. We're going to reference a base demand. So what that says is at $1,000 price point, we would expect to sell 40,000 units. And then we need some demand elasticity. Okay? So this characterizes how quickly the demand drops off as prices increases. Okay? And I'm going to give this elasticity of 3, say. So what I need to do now is go over here to units sold, and I need to say, well, the units sold is going to be kind of a function of the relative price relative to our base price. So I'm going to take the price minus the base price divided by, thank you, divided by the base price. So that would give me a sense of the relative price relative to the base price. And then I would just say the kind of standard common demand elasticity model is to say that that's just the exponent of the demand elasticity times the relative price. Okay. And finally, we need that times the actual base price to put it relative to that. So that's kind of a standard, I'm sorry, we need that relative to the base demand. Now, it didn't put that arrow in, so I knew I immediately made a mistake. Nice thing. Okay, so if we look at this right now as a graph, okay, we can actually see the demand elasticity curve there. You can see how price on the x-axis increases, the demand drops off. And when we go over and we look at, I just closed the module. Go over and we look at profit. Now we can actually see that the profit curve has a maximum in it, because as we raise our price too high, demand drops off, we make less profit. Okay? So that's, again, this was kind of a real quick example to just kind of get you comfortable with this. Okay? It's a very friendly tool. It's fun to use, and analysts love it. So you can get in there, you can build these models, I think easier than Excel, and gives you an idea. Okay, so we're going to go into the second case study right now, ML. Why don't you go ahead and present that?
We need to go fast.
Yeah.
I'll summarize the ML case, basically in which sense it's different or in which sense it was challenging. This is, as Lonnie mentioned, a multi-company holding, electrical holding. They have 6 electricity distribution company, 1 transmission, and several others, non-regulated business. The point there is that they consolidate financial statements on a holding level. And the other challenging task for them was that they have cross ownership. Some companies has part in some other companies. So produce the financial statement for them were quite challenging. At the same time, formally they belong to PPL, Pennsylvania Power and Light, which is a company that has a very strong planning culture. That is, every assumption that is made in the business plan, it's challenged. They want to not only to know what is a business plan, but how much at risk is in that business plan. Okay, I guess we should skip this.
Yeah, let's go. This is a standard picture of what they were doing. You can probably get the idea from looking at that. And their motivations for doing this, modeling these cross-ownership interactions that were impossible to get right, rapid scenario analysis, collaborative experience. And let's go into model a little bit more. Should I say a few words about scenario analysis at different types, or do you want
Yeah, I'll raise the point right
Okay.
now. What we learned from them is when they asked initially for scenario analysis. And in fact, we learned that they have like two types of scenario analysis. One is the one that is conducted by analysts at the very beginning, in the middle of the process, when they are challenging assumptions. Yeah, so you test your business plan. You test whether the oil price will be what you are saying or what under different assumptions of oil price, how the P&L, how the balance sheet will look like. That is something that is done at analyst level. So I guess we already proved that concept.
Yeah. So we
do
saw
you
that.
remember?
We saw
Let me follow. Do you remember we created a variable here, the total number of customers that were adjusted according to the date, the starting date, yeah, the date of change.
So you can think of that date, the date at which the government program is going to start, as a scenario. Okay?
That's an assumption.
Yeah,
It is supposed you plan over that uncertain variable. You don't know. Okay, we are leaving. It is not something sure. You know when that will occur. So you want to test the hypothesis. They could happen early or later in time. So we create that variable. We expand. That variable now has a new index. And we'll see how that new index propagates entirely the model. So we'll just jump to the P&L statement and see how the P&L statement look like. The consolidated, no, let's do it by company. Now it's running. It's supposed to tell a joke while it is running. Made one up. Okay, we are ready. So you can see now we have here date of change. That's a new index that allows us to compare those two scenarios. Let's see the impact. It doesn't need to be meaningful, but let's check it. So we have the scenario for an early adoption of that plan or a later adoption of that plan.
What you guys might not be able to see in the back are that these numbers across this column are actually changing as we compare the different scenarios. I guess it's changing between, actually, let's look at the right ones. Yeah, changing from here to there.
Well, let's see.
Okay. So let's move from this real quick, though. Okay. So we've seen the sort of exploratory scenario analysis. This is often referred to as parametric analysis, also. And now there's kind of another qualitatively different type of scenario analysis.
Yeah. The other scenario analysis we refer to is, the planning process, depending on the company, takes from 3 to 6 months, depending on your culture. So there are a lot of milestones in the middle of that period of time. There are some initial submission. Yeah, you submit the initial proposal. We all know the answer of that. Reduce cost, reduce investment, and increase sale. Yeah, and then you keep on going in that way until you have your final business plan or they approve it. So you need to keep a trace of those changes, because whenever you are submitting a new proposal, you need to demonstrate how things have changed from the last one you sent. So let's show you a couple of features here. Of course, we have 4 pre-saved scenarios. In this case, we are analyzing investing or not investing, and under 2 different energy price scenarios, a base price and a low price. So I will load this 4 scenario, and I will run a dashboard that will allow us to analyze that CapEx. Okay, what we got here is, well, the P&L, which line is this? But never mind. P&L concept. Profit after tax. We are looking here, profit after tax. And what we can see below is some covenants. The debt ratio under these two scenarios. Let me make this a little bit higher. Okay. That you can see here, as soon as you do not make the investment, the debt ratio depends on how the energy price is. The difference is the low case and the base case. As soon as you start investing, the two scenarios split in four, because you have the combination of two, investing or not, and a base case and a low case energy price. Yeah, so the return on asset and the debt ratio start to diverge from that point on.
Okay.
The other issue was the one you raised. Now we are at the collaborative part.
Okay, so speed of planning is incredibly important. We know that, and I'm referring here not to the computational speed, but to the time it takes to do the entire planning process. I think Gujarov is here somewhere. Spoke yesterday. He said, he made some quote that said, like, we can't even think about doing it more than twice a year. And I think it's so common in multiple companies that this is months. So this ML case, the total process took 2 weeks to just go through one scenario analysis, have all the holding companies present their analysis up and combine them and get them consistent and so forth. The system allows them to do it in minutes now. They can analyze a scenario in minutes. And so this agile exploration of scenarios is really critical. Let's go on. Now, we're talking about forecasting and projection. I just want to make a point here. This is the other theme, you notice, focus on future decisions. One thing I notice is when I talk to people, these terms mean different things to different people. And to a lot of people, they really imply an extrapolation from historical data or a consolidation of all the projections that individual business units have placed into the system, or kind of projecting the impacts of known things like the sales pipeline. Okay? We're really seeing a need for a fundamentally different type of projection, which really relies on expert knowledge. It's knowledge that can be used to evaluate hypothetical scenarios that have no comparison in the historical record. Fundamentally new business opportunities, new business situations, and a strong variety of logic. So in many ways, it's different than how you hear people using those terms a lot of times. But this is really the focus on future decisions, new theme that we think is this new thing. So.
Generally, you get a bit of conflict between this kind of driver-based model, which you normally, you often use, or we've always used for sort of long-term strategic stuff, and then you use the budgeting and that kind of level. How do you kind of address that conflict?
That's
a very powerful strategic driver.
Yeah. Okay. So the question here is historically, people have sort of a long-term strategic objective that they use, and they have sort of an immediate, now financial type of planning objective. And those are historically done by different models. And this is a sort of fundamental point here with this integrated planning approach, in that this is a comprehensive model that actually integrates strategic, financial, operational planning all at the same time. It's very useful for the strategic aspects, because when you are looking at strategy, that's when you want to be able to go in and fundamentally understand what's going on inside. And these diagrams are interpretable by people working at that level. Okay, this is a sort of a radical proposition here, but I think this culture of producing reports and passing them up, from analysts to management, is a bunch of crap. I mean, who wants to look at reports? You don't get insight from it. It's just numbers. I mean, the people in management can look at these things, use them directly, interact with them. Okay, it's far superior to reports, and they're understandable. So
the way they plan have changed dramatically. I'm talking about Comgas, for example. They start planning. They used to plan isolated. They have some silos there. They were given a platform to collaborate. That now they are able to work everybody at the same day. Everybody having one vision of the company, and understanding the impact they produce. Understanding the information that he receives as an input, where that information is coming from, and what quality it has, and what result it produced. So the change has been so profound that it even changed the organization. After 2 years of implementing this, they create a department that is called integrated planning, where they took the guy that was responsible of each module, one from the marketing sector, the other from the price setting, the regulatory part, the supply part, and they put all together under the command of someone that was from finance, who is a chief of integrated planning now. And he's the responsible, and they have a large table where all sit together. So whenever they turn to be that they need to analyze any type of information that affects business significantly, they jump to that table and start working together. So whenever they present a result, they present on that table, because that's what supports. The CEO doesn't need to trust anymore a PowerPoint.
So in terms of the scalability and the power of the underlying model, are you saying, when you're in scenarios with 1,000 products on this market, dozens of different supply sides, those sorts of scaling parameters,
Yeah.
Are you saying that this can actually handle that and disaggregate based on drivers?
Yeah, I think those numbers you spit out are child's play. So yeah, no problem. Yeah. So, I mean, there are limits, but more like gigabytes, not those numbers. Yeah.
Very old-fashioned question, but let's assume that you still have an expert who wants to see a little booklet at the end of the process. Is that possible?
Well,
What was the
the
question?
question is, so suppose you still have old-fashioned management who want to see little booklets at the end of the day. It's all problem. And
They want to see their books.
yeah, so it doesn't, it doesn't have PDF output and stuff like this. Yeah, yeah,
Okay.
yeah. So, I mean, the basic answer is no in this system. We have not had the need for that with the clients we've done. So we've sort of, I guess,
It's like
been
it's
successful
paperless,
in.
let's say.
We've been able to
it's-
successfully transfer them to
You very-
this new way of thinking.
You very easy create
but-
new views that allows you to explain whatever concept you want. And of course, you are always able to capture you can export what you're looking at and insert in a document, in a report. Yeah, and any variable you can export to Excel to keep on manipulating numbers if you want there. But the point there is that you are abandon the system. Yeah, so.
They export main outputs to the expressions that are basically template for developing some kind of report that has to be sent to other organizations. So if you want to report it inside a tool, you can do it. But if you have some template that are used for other people that are not involved with the tool, you can report the main output per se and the normal way that you use it.
Yeah. Okay. Yeah.
Let me talk just one more thing about collaboration.
About which?
Collaboration.
Yeah. Let's go on. If you wouldn't mind, let me speak to it, and you show the thing. Go. So, I just want. We're just short on time. So, there's this basic trade-off or tension that goes on in an integrated planning environment. We have we have this model on a centralized server. It has. Everybody has access to the same model, yet we still give analysts this flexibility to experiment on their own. Okay? And so how do you manage that tension between the master model and the experimentation and exploration? And so this, at the top level here, this is really done by having a public space and a private space. It's a fairly simple concept. There is the accepted model that everybody has access to. There are only certain people who have the permissions to change this. These are the people who really have the say-so as to when a change becomes official. Okay? Then every user has their own private space, and they can have permission structures on that. They can share their models with other people from their private space. So you can go say, hey, Gabrielle, I've put this new twiddle on my demand elasticity model. Take a look at it. So he can access it. He could even modify it if I give him permissions to do that. So we have a full kind of sharing at the private model. Then pretty soon, I call up my boss. Hey, Jorge, I have a change I think would be good to incorporate into our master model. And if he's, depending on how you do this, you may have more than one person, but he can approve that ultimately, and then basically copy in the modified model and make it the official public system. There's also within model permission structure too on modules, which is sort of as you would expect it to be, so we won't go there. Okay, I think that's probably enough. Okay, let's jump forward because we have one more case study, and it's a fun one. Yeah, and I'll give you the last theme here as a lead into it, enhanced visualization. So, we all know graphs and charts and stuff. We expect those. Okay, that's visualization, obviously. But I want to kind of concentrate on sort of new, innovative aspects of visualization. So, click. So, first of these is model transparency. This ability for people, upper management, the analysts themselves, somebody who didn't build the model, to be able to look at the model and understand what it does. And people, like I say, they form these little self-contained stories that are interpreted graphically. Makes it easy to understand what's going on. Click again. Another aspect is this ability to actually view intermediate variables. Okay, and actually, graph them, see the results and stuff throughout the model. So again, it just sort of opens up the transparency, gives you an idea of what's going on inside, allows you to diagnose what's going on. Okay, so that's an important part of visualization. And another aspect are sort of beyond the envelope visualizations that give people new perspective. And in the case of Panama Canal, geographical visualization really enabled financial planners to think about certain things in new ways that they weren't doing it previously. So we know the Panama Canal. I mean, I don't think we need to do too much on this. You want to say it's the main problem?
The main problem for them is setting prices. They cannot discriminate by flag or by origin and destination of travel, of trip. So whenever they decide that a dry bulk ship will be charged, of this size will be charged, whatever, that's applied to all of those type of ships. So defining the rates for them is, well, as all business, quite critical. But at the same time, they need to take into consideration how that affects the entire world trade, because all goods are moved, have different alternative routes, so they need to calculate how competitive they are against the alternatives. So
okay. Yeah,
let's go very fast
yeah.
to show you some dashboard here.
Mm-hmm. Yeah. Okay. I think we want to jump to that video.
What we are seeing here, it's goods going to being imported to Allentown, that's in Pennsylvania, coming from this point. Yes, so we can see here the cost of the route as a standard table. The point is to show you how an enhanced visualization adds value, even though at the beginning you could think that it doesn't work.
Okay, we want to move real quick here, so I want to go to the video. I will mention the model he had up there is the real Panama Canal model that they're using. We didn't have to proprietarize that one, whatever the word would be.
We do not have internet connection here, so we record the way through for you to see. So, well, this is the real model. Now we're launching the GIS.
This uses an internet connection to pull the GIS graphical information maps and stuff from the internet, and this room doesn't have internet connection, so you're seeing a video of it being happening.
Now you see for one client, it's a liner. All the routes he used, all the routes he make, and how much, how competitive the canal is. The lines, the color of the lines indicate whether, if it's red, it is something, it's a threat, and obviously. It's a customer which alternative, it's cheaper than taking this route. If it's yellow, you are just in the middle. Now let's see, for example, another way of seeing the same information, a regional map. So here we are checking how the origin destination is Asia and the goods are imported to the US. So if you are coming from Asia, from this side, of course, the east coast is going through the canal is the best alternative. There's no way to put some goods from California going through the canal. And I guess we have a last example. That's another, it's importing from the Mediterranean. And here's the competitive routes. We are exporting goods from the west coast of South America to, oh sorry, I should pause that. There we are. Here we are evaluating, exporting things from the west coast of South America to Europe. Yeah, so you have two alternatives, one going through the canal and the other, so the Cape Horn. So it tells you that you are more competitive than the alternative there. And the last one, I don't remember, Gabriel? Bringing goods.
Looking at market segment, railroad vessel going from the grain belt from the United States to Asia. And they have many alternatives. So you have many colors. I think that the main point is that all that information is stored in regular tables, and what we are doing is linking Google Maps to that information. So the tool is very interactive with other graphical or special pieces of software that can take advantage of your calculation. Of course, it's an interactive map. You have it in the left-hand side of the window. You have the dashboard in order to select the different options that you are intending to do.
So now imagine how happy the board of the canal was when tell the analyst, okay, run me a scenario of an oil price of $100 again. It is in a matter of minutes. They can answer with this type of response.
I think that route right there is really interesting, the Northwest Passage.
Okay, I guess that's enough.
Yeah.
Fortunately, it's an expensive route. Moment.
Sled dog's part of the way, right? Okay.
Okay.
So
There we are.
I think can put up our conclusion slide, right? Yeah, why don't we do that? All right, so if you remember at the beginning, kind of said we're going to be progressing through a series of themes and kind of demonstrating these themes in a current planning system. So again, integrated planning is a pretty revolutionary idea, and it's pretty, what would the word be?
Powerful.
Well, powerful idea. That wasn't quite what I was looking for, but
He's the native speaker.
I'm the native speaker, yeah. But you know, it seems like it would be pretty darn difficult to do this, but we've actually given several examples where we've done this here and to a high degree of success. Analyst ownership and control. This concept was probably the #1 determiner of success in all 3 projects. Really, it's the critical factor, I think, in doing this integrated planning and getting it to work and be used. speed of planning, of course, dramatic differences, months to minutes in the process. Emphasis on future decisions, okay, very sort of distinguishes it from a lot of the current enterprise systems. Collaboration support and novel ways of doing visualization. I think not just our system, I think this is really the future of financial planning. I kind of evidenced that from all the ideas we heard yesterday and stuff, but I'm glad to be the one to actually show it really being done. So thank you. Okay. All right, additional questions? Oh, got a couple, okay. How about we start on this side? We commonly integrate with ODBC sources, and that ability basically has sort of been sufficient for what we've come across at the moment. And of course, we have very strong ability to grab stuff from Excel still, you know, which still comes into play.
All the companies we work for
Yeah.
have SAP system for registering the historical data, and we link with some reports, some or how you say, reports are collected from a very.
Yeah. I will mention we also have a.
We directly read the raw information. It's a TXT file.
Yeah. We actually do have a capability to link to BI systems and Hypercube systems using MDX, if you're familiar with that, directly. And interestingly, we've had that for a while, and it seems that it never gets used. So what can I say? I mean, anyway.
Yeah, one question is, what's the typical rollout time of implementations on
Mhm.
large
Yeah. Well, we have several data points. Why don't you?
A typical time frame?
So he's asking, what is a typical deployment time from start to finish on a project like this?
Well, I will describe also the process and tell you the time. We usually put in contact with the people. We interview the different owners of every part of the model. That takes place in the first week when you start a project. Then in, let's say, 3 months, we came back with the entire first draft model. And the final model is delivered between 4 and 6 months. So it is not invasive at all. If you have passed through an SAP implementation process, you know it takes a lot of time from your organization just to be developing the system. I mean, it is the other way around. Your spreadsheets speak for yourself. So after a very short overview explanation of how it works, and you gave us your spreadsheets, it's very easy to capture what's there.
Okay. We have a question on that end. Dollars. Uh-huh. Yeah. Well, we've been next to Cognos implementations and stuff like that a few times, and typical costs have been maybe 30% of the Cognos system, so kind of gives you order of magnitude. Well, I mean...
Well, it's all depends on the scale of your model.
It depends.
Of course.
Yeah.
We can tell you
Well,
separately.
the one thing about doing it as a, answering that as a percentage allows me to answer it in a way that scales with the business, you know. So, you know. So.
Have you heard about demand elasticity?
Good. All right.
Any more questions?
You had one question.
Well, I think it's the same question as the questions, it wouldn't interface then with
Well, I don't think we've done Hyperion yet, but as I mentioned, we do MDX and ODBC, and so you know that should cover both. Either of those really should be a way of retrieving data from Hyperion. So, yeah.
How do you handle different deployment environments like testing, production, and changes?
I guess you were out when we covered the workspaces.
Well, he's talking about the actual software changes. Well, the one advantage here is it's a web application, and so really to the client, those upgrades are somewhat invisible. And generally, it's in-house. Of course, there's a process that has to go on to debug it. And when it's finally considered to be rock solid, you know, an upgrade occurs, and nobody's the wiser really is, you know, kind of the advantage of being web-based, I guess. I don't really have any substantial answer beyond that, though. So, yeah. Okay. I guess you probably have a lot of input on that. You can tell us the input later. SharePoint stuff. Okay. All right.
Okay.
Thank you very
anyway,
much.
if some question, we'll be walking around there. So.
Yeah, we got lots of brochures too. Everybody should walk out with a brochure. It'll save our
we'll have some
luggage
other
on the way
demos
home.
related to different sectors. So I know the utility sector is quite a particular one, but if you're coming from other sector, let's check what's the demo most similar to yours that we have here to show you.
Good.
Thank you very much.